Number 16, it says write the expression in standard form. So basically we need to get that I out of the denominator, and to do that you're going to take the expression there and multiply by the complex conjugate. And the conjugate, instead of saying 5 minus 6i, is just taking 5 plus 6i. And that's going to get rid of the I in the denominator. When you multiply that out, I'm going to multiply the numerators. You've got to do the FOIL method. So 5 times 5 is 25. The outer term would be 30i. The inner term would be negative 35i. And the last term would be negative 42i squared. But that I squared is equal to negative 1. So basically I have negative 42 times negative 1, which would be plus 42. Then in the denominator, I have a product of a difference and a sum, which is going to eliminate the middle terms. I have 25. The outer term would be 30i, and the inner term would be minus 30i, so those would cancel. My last term would be negative 36i squared. The same thing is going to happen that happened at the top. I squared is equal to negative 1. Negative 36 times negative 1 then would be plus 36. You can combine like terms, simplify everything. In the numerator, we have 25 plus 42 would be 67. And 30i minus 35i would be negative 5i. And in the denominator, 25 plus 36 is 61. All they did was take, since 61 is the denominator, it becomes the common denominator. And so if you wanted to, you could stretch that out and say 67 over 61 minus 5i over 61, which is C. Okay, number 17, use the factor theorem to determine whether the first polynomial is a factor of the second polynomial. We are just going, the factor theorem is to take what you're dividing by and kind of like you're going to solve that. You're going to take x plus 3 equals 0, so x equals negative 3. The factor theorem says, okay, if I put negative 3 in for x in the function, or in the expression, and I get 0, then it is a factor of the polynomial. So I'm going to do f of negative 3 and put where I see x in the function, I'm going to put a negative 3. And just simplify that. That's going to be 4 times negative 27, which would be negative 107, plus 10 times 9, which is 90, plus 15, plus 3. I'm sorry, that's going to be negative 108, not negative 107. Plus 90 plus 1 plus 15 plus 3 equals 0. Because it equals 0, then yes, it is a factor of the polynomial. If it was something else, then it would not be a factor, but the result would be the remainder. For number 18, it says list the x and y intercepts and graph the function. I think what I would do is go ahead and graph the function, and we'll look for the x and y intercepts there. So let's graph that. Alright, so I put the function in my graphing calculator. I'm going to graph that, and we want the x-intercepts. So along the x-axis, what are my x-intercepts? My x-intercepts are negative 3 and positive 3. And my y-intercept Where does it cross the y-axis? Let's go ahead and zoom out just to make sure we can see where it crosses the y, and it crosses the y-axis at negative 4.5 or negative 9.5. And the answer is D. Number 19, it says write a polynomial function of minimum degree. So it just means the smallest polynomial that you can, with real coefficients within whose zeros include those listed. Both of these are square root zeros. Remember that I is a square root, it's just the square root of negative 1. Anytime we take the square root of something, it's plus or minus that value. So we say that they have a conjugate. Negative 4i has a conjugate of positive 4i. And then square root of 2 would have negative square root of 2. So we actually have 4 zeros. When we have 4 zeros, I'm going to assume that the degree of my polynomial is going to be 4. And I'm going to put these together to make our polynomial. So I've got x equals negative 4i, x equals positive 4i, I have x equals the square root of 2, x equals the negative square root of 2. Bring everything back over with x. So I'm going to add 4i, x plus 4i equals 0, or x plus 4i would be a factor. X minus 4i would be a factor. I'm going to group those two together. X minus the square root of 2 would be a factor, and x plus the square root of 2 would be a factor. I'm going to multiply this group, these two binomials together. It's the product of a sum and a difference. So I know my middle terms are going to cancel, and I get x squared then minus 16i squared. Here we have that I squared again, which is the same as negative 1. So negative 16 times negative 1 would be plus 16. So x squared plus 16 is now a factor. And then for x minus square root of 2 times x plus square root of 2, again we have a sum and a difference, so the middle terms will cancel. We'll have x squared, this would be minus, and square root of 2 times square root of 2 would be 2. So that would actually also be a factor on its own. So now we have x squared plus 16 times x squared minus 2. You'll multiply those together using the FOIL method. That's x to the 4th minus 2x squared plus 16x squared minus 32. Combine our like terms and we have x to the 4th plus 14x squared minus 32, which is C. Alright, for number 20, an open top rectangular box has a square base and it will hold 256 cubic centimeters. So that's its volume. Each side has length x centimeters and height y centimeters, and the surface area is given by the function s of x equals 1024 over x plus x squared. And we want to estimate the minimum surface area and the value of x that will yield it. So we're only concerned about the surface area, we're not concerned about the volume. They already give us a function for the surface area. We're just going to graph that and look for what gives us the minimum surface area or minimum y value and what x provided that. Okay, so I've graphed the function. I'm going to have to zoom out quite a bit for this one. And we're looking for a minimum value, and you can see that we have a local minimum right here. And we have the x is 8 and the y is 192. Our y value is the surface area. So our minimum surface area is 192 and the x that yields that is 8. So the answer is C, 192 centimeters squared when x is equal to 8 centimeters. Number 21 is asking us to write an equation for the linear function of f that satisfies the given conditions. All that's giving us is two ordered pairs here. We have f of negative 1 equals negative 5 is really the ordered pair negative 1, negative 5. And f of 5 equals 7 is the ordered pair 5, 7. and we're going to take that to write in a linear equation, y equals mx plus b. To do that, I'm going to use the point slope form, y minus y1 equals m times x minus x1. So I do have an x and y1. I just pick a point that I want to use, maybe 5 and 7, and then I need the slope. The slope is the difference in the y's, so y2 minus y1 over x2 minus x1. That's going to be our slope. 7 minus negative 5 and 5 minus negative 1. That's going to be a positive, so that's going to be 12 over 6. So my slope is 2, and I'm going to substitute that into my point slope form, which is right here. Y minus y1. y1, I'm going to use this point here, which is my y value is 7, equals 2 times x minus 5. And just simplify that, solve for y, and that's going to be our f of x. Distribute y minus 7 equals 2x minus 10. Add 7, and we get y equals 2x minus 3. Remember, y is really f of x, so f of x equals 2x minus 3, which is B. Number 22, describe how the graph of the given function can be obtained by transforming the graph of the reciprocal function f of x equals 1 over x. And so we have our original function, which would be f of x our original function is f of x equals 1 over x. And so we're kind of saying what happened to that function to get, what happens when we change that function to f of x equals 4 over x plus 5. I'm going to follow the order of operations. So the first thing that happened would be, really I take this and I take that 4 out. So I have f of x equals 4 times 1 over x plus 5. So you can start to see that 1 over x plus 5, how it's like the reciprocal function. The first thing that happened to the reciprocal function is we added 5 to x. When you add something to the x value, it's going to shift it left or right. So the first thing that would have happened was it would have shifted left 5 units. And then we multiplied the whole function by 4. When you multiply the whole function by something, that's a vertical stretch by that factor, which is a factor of 4. So 5 left and a vertical stretch of 4. So that would have to be C. Number 23, we're going to divide f of x by d of x. So a little bit of long division there. Start with your function. Make sure that you aren't missing any of the terms of that function. We have x cubed. We're missing the x squared, so that's 0x squared plus 0x plus 3. And we want to divide that by x plus 4. So I need x squared in the numerator. That would be x cubed plus 4x squared, and we want to subtract those terms. 0 minus 4x squared is negative 4x squared, and bring down the 0x. Now we need a negative 4x to make negative 4x squared. So that's negative 4x squared minus 16x. Again, we're going to subtract those terms. 0 minus negative 16 is positive 16x, and then bring down the 3. We need a 16 to give us 16x, so that's plus 16x. Or excuse me, that's a positive 16x. And 16 times 4 is 64. Subtract those. and you get negative 61. So that's our remainder. It's negative 61.